9.3 talks about graphing rational functions. So let's talk about what rational functions are. So this would be an equation where you have a polynomial in the numerator and the denominator. And we're going to actually change this, and we're going to make some that actually have a common factor. So let's think about a rational function. A rational function could be something where you have a polynomial on the top and some kind of polynomial on the bottom, something like that. That would be a rational function. So we're going to look at the 5 characteristics of a polynomial function. So first of all, let's think about the x-intercept. If we think about what an x-intercept is, it's where it crosses the x-axis. So an x-intercept is going to be where you have a 0 for the y. So if I have a polynomial function, it's going to be where that fraction equals 0. And so if you have a fraction and the answer is 0, then that means that the numerator must be 0. So this is where the numerator equals 0. That's how you find the x-intercept. Okay, let's think about the y-intercept. Y-intercept is when x equals 0. So for instance, on this particular one, if I put a 0 here and a 0 here, I would just get 4. And if I put a 0 here, I would get -9. So really, you're just dividing these to last term, your constant term. So we'll talk about y-intercept being where you put in a 0 for x. Holes are going to be anywhere on the graph where you have an x value and a y value, but it doesn't show up on the graph. And the way that we find these is by factoring and looking at the common factors. And I'll show you one of these when we get to an example. Okay, 2 other things that we're going to talk about are the vertical asymptote and the horizontal asymptote. And the vertical and the horizontal asymptote both, we have talked about an asymptote. It's a line that the graph approaches without ever touching. So let's think about the vertical asymptote. A vertical asymptote would be a line that looks like this. You might have a graph that doesn't touch. So a vertical line is a line that has no slope or an undefined slope. So the vertical asymptote is whenever you're going to have undefined y. So it is where the denominator equals 0. Now I usually use, on the graph, I'll use a colored pen. I'll use red for vertical asymptote. And I think it'll be helpful if you have a colored pencil to do that as well. Horizontal asymptote is a little different. So for a horizontal asymptote, we're going to have at most 1 and sometimes none. And the way that you find the horizontal asymptote is by looking at the degree of the polynomials. And I'll make this make sense as we go through. So if you look at the degree of the polynomials, first of all, if the degree is bigger on top, that means the numerator, then you have no horizontal asymptote. If the degree is bigger on the bottom, you have a horizontal asymptote at y equals 0. And if the degree is the same, you do the leading coefficient divided by leading coefficient. So I'm going to write my horizontal asymptotes with green. So when the numerator is bigger, no horizontal asymptote. When the bottom part is bigger, it's y equals 0. And when they're the same, you do leading coefficient divided by leading coefficient. All right, hopefully this makes sense as we get through our examples. So let's do the first two examples here. These are kind of like the parent functions of a rational equation. So let's start with each one. Let's first think about the x-intercept. The x-intercept is when you put a 0 for y. So if I put a 0 right here, a 0 would mean there would be a 0 here. So this one has none, because there's a 1 in the numerator. So this one does not have an x-intercept. Let's think about y-intercept. So the y-intercept is when I put a 0 for x. So if I put a 0 for x, I get undefined. So there's not one of these either. Okay, the next thing we talk about is a hole, and this one doesn't have a hole because it doesn't have any common factors on the top and the bottom. And now we're at vertical asymptote. The vertical asymptote is what would make this thing be undefined. So what would make a fraction be undefined is if I had a 0 on the bottom of the fraction. So I'm going to have a vertical asymptote at x equals 0. So I'm going to go to x equals 0 and make a vertical asymptote. And then the horizontal asymptote is looking at the degree of the polynomial. This one is degree 1. This one is x to the 0 power. So the degree of this is bigger than the degree of this. So since it's on the bottom, the horizontal asymptote is at y equals 0. And this is kind of a weird one because there's so many that are none and 0, but I think you'll catch this once we go. So then the next thing I would do is make a table of values. I know that x equals 0, there's not going to be anything because that was undefined. So then I'm just going to try numbers bigger, like 1, 2, and I'm going to try something between 0 and 1, like a half. I'll try negative a half, negative 1, and negative 2. And if I put those numbers in for x, negative 2 would be negative 1 half. Negative 1 would be negative 1. This would be negative 2. It looks something like this. That side goes like that. This side, if I put in 1 half, I would get 2. Oops, I think I wrote this in wrong. Let me go back. So let's see here. Negative 2, negative 1. Negative 1, negative 1. So this one goes like this. And you could put that in your graphing calculator and see that by typing it in y equals. Okay, let's go to the other side. 1 half would be 2. 1 would be 1. And 2 would be 1 half. So the graph looks something like this. So you can see how this graph never passes the vertical asymptote. I do that in red because a vertical asymptote you'll never pass. A horizontal asymptote you could pass. It just doesn't pass on this one. Let's do the other one that's a parent function. So x-intercept is going to be where I put 0 for y. So what would make this equal to 0 is if the top was 0, so this one has none. Y-intercept is when I put 0 for x, and 1 divided by 0 is undefined, so we don't have a y-intercept. Okay, let's think about the holes. And this one, again, doesn't have any common factors, so there are none. Vertical asymptote is the value that would make this thing undefined. And what would make this undefined is putting a 0 on the bottom. So I have a vertical asymptote, once again, at x equals 0. Horizontal asymptote. This is x squared on the bottom, x to the 0 on the top. So the horizontal asymptote is also at y equals 0. And just to save time, I'm not going to type this in the graphing calculator or anything. You can do that. We can make a table of values and plot the points. But what this is going to look like is something like this. And I believe on Delta Math, you'll have to find some actual points in order for this to graph. All right. I think I'll do the next one on another video.